Hey everybody, welcome back. We have a lot to do in this video, but the goal is to be able to find some z-scores. Real quick, a z-score, just so you know, another name for that is standardized score. I'll just write it down. Standardized score. So when you hear z-score, it's the exact same thing as a standardized score. Okay, so before we actually go into z-scores, I give you a definition here. A z-score, it literally just means, or it tells you how many standard deviations, tells you how many standard deviations an observation is away from the mean. Is away from the mean. This is one of those just like most important things that we're going to talk about in AP statistics. This is something that you're really going to want to have a good handle on. It's going to be used all the way up until May. A lot of ideas come from this concept of z-scores. Again, it's just how many standard deviations an observation is away from the mean. So again, before we actually do some calculations, I need to go into notation. So there's two different types. There's samples, notations for this stuff. So there's samples and populations. So if the population of interest was like PV, all the students at PV, that would be a population. A sample could be your class. You guys are a subset of that population. Okay, so again, samples are just part of the population that you pull out because it's really hard to get information on everyone. Whenever you calculate something from a sample, that is called a statistic. A population, it's like when you conduct a census. I know that's going around right now. Hoping to get everybody on that right. A population, when you calculate something from it, it is known as a parameter. Okay. So when you find a statistic, for example, the mean, this is what I've been using, the symbol that I've been using the whole time for mean, thus far in the class anyways, and that was X bar. That's the notation for mean for a statistic. Now for a parameter, and this is something that you're going to see very often, it's the Greek letter mu. Looks like this, like a really fancy N and U combined, mu. So again, anytime you see this symbol, it literally means the mean, okay? Now the standard deviation, I'm just gonna abbreviate it, the Saint Dev, we'll go with that. All right, so for a statistic, I have been using an S with a little sub X down there, okay? That's how we were doing standard deviation for samples. And then another symbol for it that applies for populations mostly is the Greek letter sigma, but the lowercase one. It looks like this. So a little circle with a line jutting outward. So again, this symbol represents a standard deviation, okay? And then for size, or like number of observations, for a sample, it's a little n. For a population, it is a capital letter N. Okay, with that all out of the way, let's do a z-score. I looked up some information earlier on one of my favorite animals. So here are some information on wallabies. Wallabies, super cool miniature kangaroos. So wallabies, their weights. Wallabies have weights. Normally distributed, which is important. So I'm saying normally, that way we know that their weights are not skewed or have like a ton of just obvious outliers, because then we wouldn't want to be using means, okay? So wallabies have weights normally distributed with, so they have a mean of 9 pounds and they have a standard deviation of 1.5 pounds. Okay, so if we had a wallaby that weighed 10.5 pounds, so I'll just make a list here and we'll find some stuff. 10.5, we'll have another wallaby that's like I don't know, a chunker, and he weighs 15 pounds. We'll have another wallaby that just got off the keto diet, so he's looking a little slim. He's gonna weigh 7 pounds. Okay, so let's find the z-scores for these wallabies. Okay, we have 3 different wallabies that we want to find. They'll have 3 separate z-scores. Okay, so it shouldn't be too hard. Like this one is really easy if you just think about it. How many standard deviations away is this wallaby from this mean of 9 pounds? Okay, and each standard deviation for these wallabies represents 1.5 pounds. So hopefully just with some intuition there, you can figure out that this wallaby has a z-score of 1. He's 1 standard deviation away. But here's the formula and how you would actually find it, okay? So a z-score, or standardized score, a z-score is equal to an observation minus the mean divided by the standard deviation. Okay, so let's do the first one. The first one, the z-score for our, I'll just do like z1. The z-score for our first wallaby, his observation weight is 10.5 pounds. We'll subtract his mean of 9 pounds, and we'll divide all of that by this standard deviation, 1.5. Okay, so we get out a calculator. Be careful when you're doing this on a calculator, by the way. You want to do 10.5 minus 9, get that amount, and then divide by the standard deviation. Okay, so there you go. Z-score of 1. He is 1 standard deviation away from his mean. And when you do a z-score, always round to the 100th place. You'll have 2 decimal points, right? So I'm going to do 1.00. It'll make sense why I'm doing this later on in the week. Always round to 2 decimal places. Okay, so that's it. That's his z-score. 1 standard deviation away. Okay, let's do the second wallaby. The z-score for the second wallaby. So he weighed 15 pounds. We'll subtract the mean of 9 pounds and then divide by the standard deviation, which was 1.5 pounds. Okay, so once again on your calculator, if you really want to do it all in one go, that's fine too. You could just put these in parentheses. So 15 minus 9, you want to do that first, and then divide by 1.5. Okay, so he is 4 standard deviations away. Fantastic. All right, let's go to the next one, our third wallaby. So he weighed 7 pounds. I'm going to include units on this one because I want to show you something. So we weigh 7 pounds. We're going to subtract the mean weight of all wallabies, which is 9 pounds, and then divide by 1.5 pounds, the standard deviation. Okay, so if I simplified this, 7 minus 9, that would give me -2 pounds, divided by 1.5 pounds. And this is why I wanted to include the units on this one. You never really have to do that, but when I'm dividing here, these pounds are going to be canceling each other out. They go away. Okay, and then let's just get a calculator out. What's -2 divided by 1.5? So -1.33333. So I'm going to write that out as -1.33, rounding to that 100th place. Okay, so very important, this right here. Z-scores do not have units. Standard deviations do, but z-scores don't. And that's what's going to allow us to compare different groups. Really powerful tool for that. So maybe up here, one more important thing, maybe just like a little side note, z-scores are unitless. Okay, and then z-scores, they're either going to be positive or negative. And so if a z-score is positive, that means the observation was greater than the mean. If the z-score is negative, the observation was less than the mean. Okay, doesn't necessarily mean it's a bad thing. It just means this is less than the mean. That's all. So he weighs less than the average wallaby. These people, since they have positive z-scores, they weigh more than the average wallaby. Okay. One more thing I want to show you, and it's going to just kind of follow along with that comparison thing that I was just talking about. Say you have, I don't know, so we got a dude named Alex, another person named something easy like James. So they are in two different classes, or they have the same class but with different teachers. So Alex took a test, and they're taking the same test, by the way. There's the teacher's edition, right? Like they're testing on the same content, but with different teachers. So anyways, Alex takes the test and he gets 92%. Okay. James took the same test, but with a different teacher who kind of likes to make it easier, I guess, or harder, I mean. And so he scores on this test is 78%. Okay. Now, the statistics on these for Alex's class, the class average is an 86 with a standard deviation of 3%. All right, so Alex scored a 92%, and this is how his class performed as a whole. Now James scored a 78%, and the class average was a 68% with a standard deviation of 4%. Okay, so you're going to see this kind of stuff a lot. So just based off of these two different distributions, they kind of tested on the same type of content, who performed better relative to their class. And how you would answer that is finding a z-score. So the z-score for Alex, I'll put z and I'll put a little a down there. The z-score for Alex, that would have been his observation, which was a 92. We'll subtract his class's mean, which is 86, and then divide by their standard deviation, which was 3%. Okay? If I continue working through this, 92 minus 86 means 6, divided by 3. So he had a z-score of 2.00. He scored 2 standard deviations above the mean. Now let's do James. So the z-score for James, so I'll do z with a little j down there. The z-score for James. So he got a 78%. We'll subtract his class average of a 68 and divide that by the standard deviation of 4%. Start working through this. 78 minus 68 gives you 10. Still need to divide by 4, the standard deviation. And hey, so his z-score is a 2.50. Okay, so James was further away from the mean than Alex was. So when we're talking relative to their classes, James actually performed better. This class performed better as a whole, but compared to their classes, James did the best because he has a higher z-score in this case. All right, so I hope I didn't confuse you on that last part, and it's something I'll clarify when we have class together. But anyhow, thanks for watching, guys. We'll do some z-scores, and yeah, see you in class. Bye-bye.